In this video, I'm going to show you guys the new plugin that I'm developing for Grasshopper called as Honeybee, which will be sitting here next to Ladybug. Honeybee is a plugin for energy and daylighting simulation, like advanced simulations using Energy Plus and Radiance. Uh, it has multiple components like Honeybee similar to Ladybug, which is the main classes, and then these components for preparing the geometry, two components for running the analysis, and some components to reading the result back in visualization. I will just like walk you through the different steps. The reason that I'm capturing this video is right now, like few people know about the project, and I talk to them and I get some feedbacks and wishes and like comments, and I think now this is the time to get more ideas involved. Boom. Okay. Um, so for this example, I selected three buildings here. This is a non-planar building, the sloped one, and the building box in the center. And then I have the side here, which I will add to the simulations. I selected one of the buildings to be non-planar to show the abilities of Honeybee in taking uh, non-planar surfaces. I already know it will add to the time of running energy simulation, especially and a little bit for daylighting, but I think it doesn't matter. Like I will just fast forward that part. Okay. So the first step is just like you have your buildings, you just connect it to the to intersection component, so it intersect the buildings, like it finds the surfaces which are shared and intersect the buildings based on that. Then you use that result of this component here, you start making your floors. So I say the first two floor, for example, are 4.5 and the rest is 3. You can like say the three next floor are 6 and the rest is something like 3.5. But like let's keep it like this because these buildings are not that tall. And at the same time, with the same language here, you can say the first floor are retail, rest is office or whatever. So it will assign, schedule, construction set. And here I have more for splitting zone into perimeter zones. It hasn't been developed fully. It should work for a geometry like this, but I'm not going to try it right now. So when I get this, there is another component that find the adjacencies, like which wall is next to which wall. As you see, these are not only geometry afterward. They have attributes, so they have a name, they have a construction set, they have a zone that they're related. And now, as soon as I start moving this here, it will update everything and the adjacency. So okay, so far so good. So we get this. Now this is the right time to add the openings. Uh, I have this component here for now that adding the opening based on the percentage and like the orientation. Of course, there will be cases that you have a geometry, everything signed. There will be another component that you can make a thermal zone, or actually I'm using these zones for daylighting simulation too, so maybe I should call it a space, similar to what OpenStudio team they call their the zones. So this is spaces. There will be another component that you can make the spaces out of a geometry that you designed, like in any way that you want. So let it run. Yeah, the reason that it takes a little bit is because I have this non-planar surface and I have to use offset curve on surface to find the percentages that I want by guess and check. Like the other ones are going to be mathematical calculations, so they're pretty fast. Okay, got it. Now it's ready to run actually, but before that, here I'm adding this geometry as a shading. uh, or context. I call it shading because again, this is the terminology in Energy Plus that you add them as shading surfaces. So I connect this to here. I connected this one to here. So I have them, and it's ready. So I just say where the location is, the weather file, and I say what are the outputs that I want. Working directory, this kind of thing, and then I can just write the IDF and run it. But before that, let me talk a little bit about this custom external line. I add this custom external lines here because Energy Plus has like I don't know how many inputs that you can change in variables. And if you want to make a parameters something like this or something like what I have for Ladybug, so you can manipulate all that data, then it's going to be like something like coming starting from here, ending here, I think. And if you're not an advanced user, probably you're not going to change many of them. So this part lets you override the classes that you want to override if you're an advanced user and you want to make a change. Like a simple example could be like time step of the simulation. So I can write time step and like 10. It is 6 by default and then connect it here. So the component will understand it and read it. Oh, time step is here as an input, so overwrites the time step that is already there. So you have control basically on every single thing that you want to change, and yeah, and you don't need to go inside the code, or you don't need something really tall here to check everything. So let me write the IDF file. Here you go, done. And before I run it, there is a component here that you can check the geometry. It basically takes the IDF file and visualize it inside Grasshopper. It could be any IDF file, so it could be the IDF file that I just wrote. So let me go turn off the preview. And the floors are here. The reason that I'm doing this is before running the simulation, you want to make sure you have the right geometry. You don't want to run it and then be surprised, you know. I think that the process of having a program that goes both way, like from Rhino to energy simulation tools or daylighting, and from that tools, bringing back to Rhino and Grasshopper is important. Again, it takes a while because you will see the mesh on this surface. Okay, here you go. So, and I connected them to different colors, so they're colored based on the type. Like the walls are yellowish, yellow-green is roof, and then you have glasses. So you see what's happening. These surfaces are all meshed, and if I zoom in, it's actually meshed and offset because all the windows should be a child in Energy Plus. And this is the only surface which is meshed. Like all the others are clean because there's no need to be meshed. However, it's a closed VRAP still. So I've worked on different ways of meshing the geometries, like cleaning them up, how I can prepare it. And I think it's the one that I'm doing right now is pretty much sophisticated in taking geometries and simplifying them in this way. So okay, I have it. It looks good. I can't see a problem with the geometry. Here is something interesting that we should see how long the simulation is going to take. Probably if it takes long, I will just make it go fast forward before I upload the video. So done, run. So as you see, this is the energy plus. This is actually a batch file running the energy plus, so it's warming up. Oh, and analysis period, I left it empty, so it will run it for all the year. Well, it is slow, but not as slow. Yes, I think I will fast forward this part and then I will show you how you can visualize the result. Okay, the result is here. The simulation is done. This is the error file or report file. So this is the first file you want always to read. So I have 19 warnings, which is okay. one severe error. Stop that, but let's see what is the error. It says this vertices, the duplicate, it will be removed. Okay. It talks about that the shared wall, which is okay because in my library I have only one type of wall, and it's not mirrored, but because the U value is the same, so it will just continue simulation. Okay, if you want, you can add, as you see, you can add something, check more, but like for now, I want just to show how it works. So I have a component that read the results from the address, and as you see this, you can see this is the uh, heating load, and this is the cooling load of these buildings, all the buildings together, and then here you can get it like for each zone. And monthly cooling, monthly heating. So I can use these values and just color the zones, right? And then I can type, like, I can see how much each one is going to use, like, and then definitely I can do, for now I'm doing like total per square meter, cooling per square meter, heating per square meter, or just like, what about total energy use? And you see these buildings, because my roof construction is not such a good one, like the ones on the top are using like the most amount of energy, like, well, per square meter is a better way to compare. In the building, in each building. So here's basically what you can do with energy simulation. So you can get the loads. Now I can do like fast change, for example, change the percentage of glazing on the west and see the effect, like boom, it will redo everything. You can just make something smaller, bigger, but because we have this non-planar thing, I'm not going to do that. It takes a while for running the simulation again. So this is the energy part, but I think an interesting part of Honeybee is you can run daylighting simulation for the exact geometry with no change. So I have this geometry from here. Instead of going that way, I should go this way. There is a component here for running the daylighting simulation. For daylighting, you can see you get kind of more input right now. Similar to energy simulation, it needs the geometries. It imports some test surfaces, and by test surfaces I mean like from test surfaces you generate the grid, the test grid for running the simulation, similar to what you have in Ladybug. But there are small differences here. Here you get the option to like using endpoints and normals instead of a test surface and grid size and distance. Either way it works. Then you can import the radiance parameters. These are the advanced radiance parameters, like how many times do you want the bounce and all this stuff. If you just leave them, they have all default values. I put it to 2, so it's be pretty fast. I mean, by fast, I mean fairly fast. And the shadings are added here from the same component. You can overwrite the reflectivity of vertical, horizontal, or you should be able to overwrite the materials. But like inside the components, what I do is I read the material of energy simulation and use them for the material of radiance actually. But you can always overwrite them if you want. And there is an analysis recipe here that you say what kind of simulations do you want to run at the same time, and I put it in a way that you can run this and that more than like let me run this now and then run again the other study. So let's do this. I want to run an analysis for radiation. I want to get the image like in this view. You can add multiple views, Rhino views, and it will just run it for everything, but like let's just do it for one for now. Let's look at this view. Probably is going to give us a good picture, and I want to run the daylighting simulation too for the and see how much daylight I receive inside the building. You can say when. Now it should be for 21st of December and at 12 o'clock, and you can like define what sky condition do you want, uniform, cloudy, blah blah. And there will be a climate-based simulation here. I haven't made my decision which way is the best way to go right now. Uh, I'm still thinking about it and talking with some people to see which way is the most efficient, because this one is going to be fairly long when you run the analysis. So we are ready. We only need to know the test surfaces for the daylighting simulation. So I can use this component which select the with filters actually the surfaces based on the type. So if I turn on the preview, I can see the floors, right? Show floors, and these are the floors. Or I can run the simulation on the walls if I think like the walls are the test surfaces that I want. For now, as I said, I want to use the floors because I want to see the daylighting, and I will call here half of the surfaces because I don't want to wait here forever. Right? Looks good. And I use these surfaces, connect them as test surfaces, and let's set a grid of 1 meter and the distance of 72 centimeters from the floor. It should be how many feet? 2.5 feet, something, hopefully. So again, similar to what we had, I write the RAD file first before running anything. I check my points. Okay, fairly dense grid. That's good. And then I can connect the RAD file address and see if it's exported in the right way. I have an option here that you can either like only see the wireframes, or now it gives you the surfaces, real surfaces. So I can, for example, check the normal of the surfaces to be right. Like, let's check the normal of the walls. Yes, looks good. Everything in the right direction. And again, you see like only this one is meshed and the other ones are clean. Let me do, probably I should disconnect and connect. So it's just removing all the outputs one by one. Yeah, there are limitations in the Python component to control, and I don't have a full understanding of how the component works, but it works for now. So you see that now you can see how it's written as a polyline, because it's different how you write it in the radians. So it's actually a polyline going like this, and then you have a surface inside. Okay, everything looks good. Uh, so I can run the simulation. Again, I set the right view that I want. You can set up a view and just connect the name here. Okay, go. So now it generates the sky for radiation study first. And make the scene that you want to run it, and now it's running the rpict, which generates the picture. Yeah, the Radiance is a validated simulation engine. It's not like Energy Plus. It's more geometry friendly. It's basically accept like all the surfaces are like mesh surfaces having properties, materials, and it runs the ray tracing. It has a really good supporting group, a really active forum, nice people. I mean, I really recommend you, because energy simulation is something like designers. It takes a while to get used to how it works, but daylighting simulation is fairly easy to start and understand, and you will get a really good support if you have any question. In any case. 41%. Probably I have to fast forward this too. Okay, it did it. It converted it to a TIFF file and a GIF file from the pic. Um, Now this one is art tracing, and it makes the sky for the daylighting simulation based on the inputs that we have for December. It was December 21st at noon for a cloudy sky, and it's running the daylighting simulation for that time done. So we got it. For the picture, I should go to the folder. So see backslash honeybee tower 821. It's tower 821 because I named it this. Why I named it this, I don't remember. But anyways, uh, here is the GIF file. The same, as you see, the same camera, the same view. Wow. Excuse me. Oh, if I can drag it. Okay. And then there's a TIFF file, which is high resolution if you want to use it for a presentation or something. And the address of the GIF file will come here as an output. I wish there was an image sampler in Grasshopper that could accept the address from here, boom, so you could see it, but there is nothing like that, or I don't know about it right now. And then you can do so much, like you can import the radiation results, for example, in a view, and use that picture as an attractor, the values of the colors, because the colors are representing the amount of radiation that you get. So, for example, you can do it for the top view and then design a site plan based on that. And it's much faster, sort of, and it gives you like lots of opportunities. I will definitely integrate these presentations inside the components, similar to what Ladybug does now. But like there are a few differences. For example, now I graph the data, so not only you can see the result for each point, but you can see the result for each floor, like the average value. So it will give you, if you design, for example, a neighborhood, you can see, oh, here's where the problem is happening. And definitely you should look to the numbers, not to the colors. So what is the minimum value that I got? Well, the average is high actually. And what is the minimum value before 69? Not that good. So and as you can guess, you can, yeah, the values you can see it here. So like you can use all the inbuilt native Grasshopper components to, like, for example, to dispatch the data, so you can find where is that 69 happening and make your design decisions, change it, go to the next level. And the reason this guy is getting so high, because when I move the points up, probably some of this could be out and getting like crazy amount of daylight. Well, I think that's it for now. I can run radiation analysis, but it's going to be similar, exactly similar to what's happening now in Ladybug, but like much more accurate. I can't remember of anything else that I want to say. Yeah, let me know what you think, and if there is anything special, suggestions, wishes, they're all always welcome. And thank you for watching this.